All right, your next section of notes in our probability statistics little mini unit are on permutations and combinations. Still going along the theme of counting possibilities. So these are a little bit more involved. Different categories are involved in here, so a little bit more difficult than just the counting principle. The hard part is trying to figure out when you get to use permutations, when you use combinations, or when is it just straight up counting principle. So we're still trying to figure out total number of events or outcomes in a specific situation. So again, a little warm up, list all the different three-letter arrangements using the letters in math. So using the letters M-A-T-H, come up with all the different three-letter arrangements, only using 3 out of those 4 letters. Doesn't have to create an actual word, just the different 3-letter arrangements. So if this would be a good time to pause, it does say to list them. So take some time with this and let me see what you got. So a good majority of you guys may have, oh, it's not showing up. Oh, I guess I had to erase that one. Good majority of you may have just shown what I have here in orange. And so in orange, we just came up with 4, right? And so then others may have come up with 24. So the question is, who's right? Is it 4 or is it 24? If you notice, for the 24, I went through all the other orders using those same 3 letters. So I guess the question comes down to, does order matter? Is MAT the same thing as MTA, TMA, so forth and so on? So that is really the difference between a permutation and a combination. Now, in this particular case, I wasn't clear on purpose. I wanted to kind of get you guys thinking and understanding that there are a couple different options here. So if you were one that said the 4, then you're talking about a combination, that you basically said order doesn't matter. But if you got 24, you're saying, no, those are different things. So in life, there are times where it matters and there are times where order doesn't matter. And so that's why we have the 2. And how we count up and total the 2 makes a big difference. As you can see here, it's a difference between 4 or 24 in this answer. So it can definitely change an answer quite a bit. So a formal definition, a permutation is an arrangement of a group of objects where order is important. So for the permutation, I would say 1, 2, 3 is not the same as 3, 2, 1. Order is important. In a combination, order is not important. Okay, so 1, 2, 3 is the same as 3, 2, 1. So let's just kind of go through some different scenarios. I have a bunch of scenarios listed. And usually when I would do this live, we would just drag and drop these into different spots. So that's why they're kind of written that way. But we can go ahead and label these as we see fit. So, digits of a phone number. Do you think order is important? So think of a phone number, even just think of the last 4 digits of a phone number. Is the phone number 1, 2, 3, 4 the same as 4, 3, 2, 1? No, order definitely matters here. This would be a permutation. I'm just going to put a P for permutation. You can put perm. I suppose we could put perm. Passwords. Obviously, order matters. Letters and numbers and symbols, where they're at in the sequence, definitely matters. Selecting people for a team. Now, as far as your pride being hurt, if you're selected last, it really doesn't matter. If you select 3 people to play with you, it doesn't really matter the order in which you select them. They're still on your team. So that would be a combination. Social security numbers, that's obviously the order. Perm, it's who we are. That's your identity as an American. Putting groceries in a grocery cart. So when I go shopping, again, instead of preference, you can't just say, oh, well, no, I have to have the eggs on top, or I have to do produce last, or, frozen foods last. No, it's just when you put apples and cereal and green beans in your cart, it doesn't matter the order. When you go to check out, green beans, apples, and cereal are still going to be there. The order in which we put them in the cart has nothing to do with that. So we wouldn't count that twice. Locker combination, this one always throws me. Okay, the companies like Master Lock put combination in there. We always talk in terms of combination, but actually it does matter. And so this would be considered a permutation. They should actually be called locker perms, not locker comms. Adding test scores to average. So if you're trying to figure out your average grade, do you have to do your first test plus your second test plus your third test? Or if you change the order in which you did your third, your most recent, then your last one, it doesn't matter. Your average will still be the same. That would be combinations. Okay, one of them I do want to reference here. Sometimes you can give a little bit more detail and make one of these combinations into a permutation. For instance, selecting people for a team, that's a combination. But if they have actual like captain or co-captain or spirit captain or something like that, now the position matters, because even though you have players 1, 2, 3, 4, 5, well, what if 1 and 2 were captains? What if 3 and 4 were captains? Those are different instances. So when you give some information like a position, like captains or leaders, or sometimes even selecting somebody to be a part of a council, but then maybe we give them president, vice president, we give those designations, then it would change it to a permutation. So sometimes just more information or more details changes that slightly. All right, so here are the formulas for these events. I'm trying to hide the other ones just because I don't want you to really see them right now. So obviously permutations are going to have more choices because we count 1, 2, 3 and 3, 2, 1 as different. So we have quite a few then underneath each of those things. So you're going to see these excited ends, and I'll explain to that. That's an actual mathematical symbol, so that exclamation point actually means something here. So if you're using all the objects, that means that I have, like in the words math, right? So we had the letters math. I wasn't using all 4. I was only using 3 out of the 4. So that would not apply here. If I was going to use all 4 letters, then it would count. So how many 4-letter arrangements can be made using the letters in this 4-letter word? That would be, and if you want to put this over here, that would be P, I have 4 and I'm using all 4. Okay, that's how they write that. Another way to write that is you have the 4 and the 4 here. This is how many total you have, and this is how many we're using. And so to calculate that, it's called n factorial, which would be 4 factorial. And I'm going to explain that at the bottom of the page. Factorial is just a mathematical operation. I can tell you right now, it's just taking that number and multiplying it by each subsequent number below it. 4 times 3 times 2 times 1. And that's where we get the 24. You actually get 24 if you use 4. We also got 24 when we used 3 of those letters, right? Okay, so the formula changes slightly if you are changing only 3. Now, I said the formula changes, but sometimes you get the same answer. So selecting our amount of objects, the number you're selecting goes second. So in that example that we had in the beginning with that warm-up, we'd say I had 4 letters and I'm using 3 out of the 4. So that would be permutation for 3. Okay, and what that looks like, slightly different. You're going to put the 4 factorial on top, and we can just put this off to the side. And then I would have whatever 4 minus 3 is on the bottom. And now you can see that it's 1 factorial. So that's why it doesn't change anything. That's why we get 24 either way here. Now your calculator has this factorial button, this little exclamation point. It also has a button that looks like this. Okay, so you'll be able to just fill it in. You would put 4P3 and it'll do the math for you. So there's times where I'm going to have you guys show your work on these, and then there's times where I just want you to use the formula. Okay, also, when objects repeat, look at this example over here. How many arrangements can be made using the letters in banana? So we're assuming that we have all 6 letters and we're using all 6 letters. Well, in the word banana, A shows up 3 times and N shows up twice. So I don't want to, depending on where that letter is, it doesn't count twice it would give you the same result. So there's going to be a lot of repeated words or combinations because of the repeat letters. So we have to adjust for that. So how we adjust these formulas for that is you take n factorial over, and then however many times things repeat. So in this particular banana case, we have 6 letters, 6 factorial, but then the A repeated 3 times, so that would be 3 factorial, times the N repeated twice, so that would be 2 factorial. If there was more repeats, you just keep adding them on in the bottom. It doesn't matter the order. I did the A's first, then the N's. It has absolutely nothing to do with it. Notice it says P and Q represent the repeated objects. So total object on top is your N. N is always your total amount. And then from there, the repeats. Now we can show some work, we can show partial work, we can figure these things out, but I'll show you that in a second. N factorial reads N factorial. That's just that explanation point, and it's the process of multiplying N by all the preceding positive integers. So I showed you up above 4 times 3 times 2 times 1, and that becomes 24. But you should have an N factorial button on your calculator. Look in the second buttons above your keys. Sometimes you just have that key. Also, for your homework, there might be a probability, a PRB button that stands for probability. Might be above that, but when you go into that probability button, a lot of times there's several different choices there. So not talking the graphing calculators right now, just your scientific calculators. The graphing calculator has it as well. I believe they have it under math. And math, I believe you would just arrow over because they have a whole menu of probability. So under the math option of your graphing calculator. I might be corrected by that. We'll find out. For combinations, they have formulas too. How many different teams of 3 can be made out of 5 different students? You have to select an R amount of objects for combinations, because if I asked you for the combinations of 4 letters of math, MATH is just 1, because ATHM would be the same combination. So there has to be, you have to do 3 or something like that. So it says how many different teams of 3, so 3 people can be made out of 5 different students. So we have 3-person teams, we have 5 people to select from. That would be combination 5, choose 3. Assuming that person 1, 2, and 3 is the same team as 3, 2, 1, right? There's no specific titles to them. And so when we set that up here, a little bit different than the combination one, we'd have 5, choose 3. On top, we'd have 5 factorial. On the bottom, we subtract them, so that would be 2 factorial, but then we also times by the 3 factorial. Now, a lot of the stuff will cancel. So when we do show our work, we only show our work to a certain amount, and then things start to cancel. I'll show you in the examples. If you have multiple events, you multiply the different permutations and combinations for each event. So sometimes an event might be choosing a king and then choosing hearts or something like that. You'll see that show up. You just multiply the different events. You're choosing 2 different things, so then you have 2 different events. So you just multiply those together. All right, so let's go ahead and try some of these. So first example, 8 people enter the best pie eating contest. How many ways can blue, red, and green ribbons be awarded? So there's 3 different ribbons, right? And we had 8 people. So we have to ask ourselves, does it matter what ribbon you get? Well, yeah, the blue ribbon is first place. Red is second. I'm assuming green is third, right? So the first thing you have to do is identify that this is a permutation, right? And then after we identify that it's a permutation, it is 8 permutate 3. Because even though you have people 1, 2, and 3 win, 1 could be the blue ribbon winner, 2 could be the blue ribbon winner, and so could 3. So that's why it's a permutation. So look at your formulas. We're going to use the formula where we have amount and we're choosing a certain amount. That is 8 factorial over 8 minus 3 factorial. I like to show my work. I like to see what everything is. Now for 8 factorial, this 8 minus 3 is going to become 5 factorial, right? So 8 factorial over 5 factorial. But here's the thing. 8 factorial has 5 factorial living inside it. So I'm going to extend this out 8 times 7 times 6 times 5 to the end. I'm not going to write out 5 times 4 times 3 times 2 times 1 because I have a 5 factorial down here that are the same numbers. So I could write them all out, but then I'm just crossing a bunch out. I'm going to cross the whole thing out. The fact that 5 factorials cancel, and so this just becomes 8 times 7 times 6, which is equal to 336. So there are times where I want to see that work. Now, let's look at it if we had our formula. Okay, so for our formula, try to find these keys on your calculator. I'm going to put 8P3, and it should give me 336. So it's kind of nice. You don't have to do all that work, but I like to do a little combination of both because I want to see the work and so that you know the formula, what the buttons are doing, but then also it's nice in a pinch just to have that little button. Number 2, how many different ways, sorry, spelling, can the letters of Mississippi be arranged? We're using all the letters, so combination is out because we're talking about arrangement of all of them. And I use Mississippi because it's got a lot of repeat letters. So there are 11 total letters here in Mississippi. This is obviously a permutation. Okay, and so remember with the repeat, you take the amount that there are, 11 factorial, and then each of the repeats we got to put under as factorials. So I have 1, 2, 3, 4 i's that repeat. So we don't want them to repeat in their counted double. 1, 2, 3, 4 s's. And I have 2 p's. Doesn't matter the order in which you select them, but all the repeats have to go on the bottom. I could list them all out. I could go through the whole thing. I can go down to 4 factorial, 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial times 4 factorial times 2 factorial. These 4 factorials go away. I could put that into my calculator. I can count this out 4 times 3 times 2 times 1 times 2 times 1. And when it's all said and done, you get 34,650. So this one you cannot do the shortcut. You can't use the formula because you have to do that other part of it. This part of it makes it so that you can't. So I don't need to see all that written out, but you do need to keep track of what you have going on. So maybe you write the number for 11 factorial, and then you write what you're dividing by, so you keep track of everything. Make sure that you're not miscalculating. Number 3 here, 5 cousins. Oh, sorry, I didn't get to number 3. 5 cousins, so 5, at a family reunion decided that 3 of them will go to pick up a pizza. So we're choosing 3 out of the 5 cousins to go pick up the pizza. How many ways can they choose? Geez, I can't spell. The 3 people to go. So it doesn't matter who's sitting shotgun or who's sitting in the back or who's driving. We just have a combination here. And our combination is 5 to choose, and we're choosing 3. So that would be 5 factorial over 5 minus 3 factorial times 3 factorial. Just showing the work. which then simplifies to 5 factorial over 2 factorial times 3 factorial. And when I expand it out, I'd have 5 times 4 times 3. My 2 factorial becomes 2 times 1. I'm going to leave 3 factorial as it is because they will cancel. That's a 3 times 2 times 1 that's going to cancel on top and bottom. That gives me 20 divided by 2. 20 divided by 2 is 10. Now we have our total. So once you have your total, you can make lists. Obviously, I can list 10. I can't list all the different combinations of Mississippi or all the different ways to write Mississippi, 34,000, but 10 would be doable. And knowing the end number would help us make our list, but it also will help us in probability in a couple of days from now. Also, if you would like to try it really quick with your calculator and just see if you do get 10, using the calculator buttons, 5, choose 3, and simply hit enter should give you 10. So you have the work for it, but you also have the little shortcut formula. All right, so this section here, you need to have some understanding of a deck of cards. And I have a little cheat sheet for all of you that I can give you just to understand. Not everybody plays cards anymore. So there are 52 cards in a deck, separated into 4 different suits. You've got clubs, you've got hearts, you got spades, and you got diamonds. 2 of those are red, 2 of them are black. So half the deck is red, half the deck is black, and there are 13 cards in each. There are aces, which has an A, all the way up to numbers 10. Ace really stands for 1. Sometimes it's considered the highest in the deck, sometimes it's considered the lowest, like a 1. And it then counts 2 through 10. And then you have face cards. You have a jack, you have a queen, and you have a king. So like I said, I'll give you a little cheat sheet of those. But this is asking 6 cards are drawn. So we have a total of 6. From a standard deck of cards, that's 52 cards in the deck. How many hands consist of 2 hearts and 4 spades? So we're just talking about the suits right now. So each suit, that's your hearts and spades, has 13 cards. So what they're asking for, it doesn't matter the order in which you hold them in your hand, it's a combination. So we have combination of, I have 13 total cards, 13 total hearts, and I'm choosing 2 of them hearts. And then I have a combination of 13 total spades, and 4 of them are spades. Doesn't matter the order in which I pulled them. So this would be our hearts combo. This is our spades combo. So this is what I'm talking about with the multiple. Okay, they have the and here. We're going to multiply these 2 together. So it's going to become 13 combination 2 times 13 combination 4. And I'm not looking for all of that mess. When it's all said and done, I believe it's, if I'm correct, 50. That just doesn't make sense. Let me check my math really quick. Yeah, that's correct. And it is a lot. You have 13 to choose from, and you're only looking at combinations of 2, and then all of these, and then you multiply them together. So the multiple events we multiply together. So for your practice problem, lesson summary practice problem part, describe a situation in which the outcomes were the following, and then find the outcomes. Let's go ahead and, for this one, let's go ahead and use the formula. You can use your calculator. And for this one, let's show our work. But come up with a scenario. You come up with the question and then actually figure it out. Good luck.